happen. I bumped the control. Sorry about that. With 31 watts forward, the reflected is about, I hate this phone. The reflected is about 2.8. And that calculates to 31 plus 2.8 divided by 31 minus 2.8, an SWR of 1.19, 1.2 to 1. Calculated, wound, no adjustments, first time, works perfectly. You'll be hard pressed to get commercial equipment like this that has any less than about a 1.4 or 1.5 to 1 VSWR. And it goes down to about 1.14 on 160 meters. I had to start with the differential equation for inductors. I found a golden formula for calculating this precisely. No guessing, none of the nonsense that Kiekert was spewing in his book of square roots and calculating and guessing and putting on turns and seeing if it works. So this indicates that he didn't know what he was talking about. It's easy for engineers to play expert and throw around a bunch of technical terms and not really know what they're doing. And I didn't either. I didn't know about this until I forced myself to sit down and do the complex math. And what jumped out at me was how insanely simple the formula to calculate this is. You wouldn't believe it if I showed it to you. A drunk fifth grader could literally calculate it. So what this is 8 turns primary, 19 turns secondary. They're interleaved. If you see kind of groups of 3 turns, the secondary turns are separated with a primary turn in between, and since the ratio is 2.3, and I measured the inductances by resonance, I calculated the ratio, it came out exactly 2.3, 2.29. So close it isn't worth arguing about. Perfect. And to get to 2.23, there's some secondary windings hanging off the end, which means a little bit of uncoupled flux. But got exactly the ratio I wanted the first time it was wound. Why hobbyists and many engineers can't do this? The math is manipulating a differential equation and 3 calculus integrals. They're very easy, but this is a rather complicated and a bit confusing process, because then it requires taking a formula which has no meaning as far as a transformer goes and doing circuit analysis, then deriving a formula. And if I showed you what the formula was, you would laugh. It's almost childish, and it works. I wound it, threw on turns, stretched them a bit, got exactly the right inductance, wound the secondary, bang, it's perfect. And I've also found a way to predict the corners of the frequency response where it starts rolling off. And that's by the calculation for the primary and by the uncoupled flux measurement afterwards as the limit for the high frequency response. I tried to test that because I calculated the high frequency corner at 65 megahertz. But this core will not work that high, so I can't test that. So 1.8 megahertz, 1.14 SWR, 40 meters, 1.16, 10 meters, 1.18, 20 meters, 1.23 to 1, 30 megahertz, 1.67 to 1, still operable, but getting to be a little high. At 40 megahertz, it was 1.6. That's about what commercially bought equipment would be. At 50 megahertz, it was a 4 to 1 SWR, so it just went off the charts. And the reason for that is the permeability chart for 52 material. If we see at the bottom, 10 million hertz is 10 megahertz. There's a knee up there at 8 megahertz, right up here. That's 8 megahertz. If we take that knee off and roll that, it's pretty much a flat response from 1 megahertz to 10. Then it starts rolling off significantly down here. Don't know what that was, but the mu prime goes from about 250 down to 200 at about 10.5 megahertz. Each division down here is 15 megahertz would be in the middle. That's 20, 30, 40, 50. So each line is 10 megahertz. So at 20 megahertz, it's the permeability has gone down to about 100 and something, 120. And it's still in the ballpark, but the coupling begins decreasing. So that means that the resistive image coming in is no longer correct. Get that reflection out of there. So the resistive image, the image transfer is messed up. So I intended this for 75 meters only. I really can't operate on 40. My antennas are too good. That would be an FCC violation to run 600 watts for me on 40 meters because I'll just blow everybody's doors off. I'm doing it with 100 watts or less now. So this is for operating AM on 75 and for operating phone daytime on 75. So it's basically perfect. That's down there on the third line before the knee of the permeability curve, before the roll-off. So that's why, if you look way down over here, 20, 30, quit that. So 50 megahertz is 20, 30, 40, 50 right here. And the permeability is starting to crater. It's down to about 85 instead of 200. So that's why the SWR goes through the roof. Now, as I also showed you before and predicted, at this point, the low-level test equipment is worse than useless. Even the HP and the Tektronix stuff, worse than useless. I tested this with 2 volts peak-to-peak from the HP generator and into the tech scope, and I arranged the 115 ohm load, so the 50 ohms of it was a tech scope. And with 2 volts peak-to-peak in, it should have been 2 volts peak-to-peak out. At low frequency, it was 1.3 volts. So severe failure. And that's because the core doesn't have enough energy to couple. And that's why I told you in the video about why you cannot use balance on receive. That's proof. And that's at 2 volts peak-to-peak, not 20 microvolts. At 20 microvolts, that core is doing nothing. So, cannot use toroids and balance and this nonsense with receive antennas. It's a power transformer. It's a power inductor. It's got to have some power to excite it. So what that means is that as the AC, the RF sine wave goes down, even if it's driven with 50 watts, when that wave goes down to a couple of volts, then there will be significant distortion and some mismatch down at the very low power levels. Just one of those deal with it things we really can't do anything about it. Okay, the winding, this is a pretty sloppy primary, but I'm going to leave it because it's lower capacitance. If you see the plastic strip down in there, the 2 secondary windings are separated and a primary winding put in between them. But that means that the primary windings have to cross over the secondary down here, and that'll cause pinching and rubbing and shorts. So I put a sheet of HDPE plastic, probably about 15 thousandths thick, here. And that separates the windings and greatly reduces the capacitance. So there's a trick for not having the windings short on the inside of the core. On the outside, we just go along and separate the windings out. So low RF voltage, no heating in the core or wire whatsoever. Can't feel any. It's just beautiful. except the winding's a little bit sloppy. So if I wanted to be artistic, I could rewind it, but what's the point? That's what ham radio is about. 50 years from now, they'll be admiring my work and saying, look, that must have been hand wound. Yeah, that was perfect.
You look like a master to me.
All right, Leroy. Who's the one and only master?
Yeah, I am. Match me.